Okay, just so you know, so far the theme song for Batman has been suggested, and the song from SpongeBob. Although the person who suggested that rewrote all the lyrics to be Miss Nagel Perkins. I'm not singing, so that one may not ever happen. Okay, yesterday, and I forgot about not saying okay anymore. Yesterday we did, or today in class we did substitution. So we had one equation that we solved, and then we substituted into the other one. Elimination, we're going to actually get rid of one variable by adding or subtracting our two equations together. So let me show you what happens, and then we'll sum it up. So like in number one, you'll see that you have plus 2y and minus 2y. So if I take these equations and I add them together, 3x plus x is 4x, 2y minus 2y is 0, and 5 plus 1 is 6. So now I have 4x equals 6. Easy to solve for x. X is equal to 6 over 4, which is the same as 3 over 2, which is the same as 1 and 1/2, which is the same as 1.5. And it doesn't matter which way you write it. But remember that you're going to go back and substitute. So now I know what x is equal to. I can take either one of my equations, whichever one looks easier to me. In this case, I think the second one looks easier. And I'm going to substitute my 1.5 in, and then I'm going to solve for y. So I'm going to have x minus 2y equals 1. I'm going to put in 1 and 1/2 minus 2y equals 1. I'm going to subtract 1 and 1/2 from both sides. Oops, 1 and 1/2. So I end up with negative 2y equals negative 1/2. 1 minus 1 and 1/2 is negative 1/2. I'm going to divide by 2. Y is equal to a negative. If I do 1/2 divided by 2, I'm splitting my 1/2 in half, which makes it 1/4, or 0.25. So my solution is 1 and 1/2 and negative 1/4. That's my ordered pair. So here's what I do to solve by elimination. I make either x or y, it doesn't matter, one variable the opposite of the other one. Okay, I solve for, or I add, and solve. Then I don't know if that, maybe that was 2 steps. And then I substitute. And solve again. And hopefully then I'm going to have an ordered pair. Okay, so I'm going to make one variable the opposite. Sometimes I have to multiply. Then I guess we'll put add and solve right here. Then I add the two equations together and solve for one variable, substitute it into either equation, solve for the other variable, and then I have my ordered pair. So let's try number 2. Already I have a negative, and this is something to look for and go, ooh, elimination will work really good. If I have the same variable in front of, if I have the same coefficient in front of the variable, that means it's going to be easy for me to add because negative 5x plus 5x is 0. 3y minus 2y is y. 5 plus 1 is 6. I can take either one of my equations that I have and substitute back in the y and solve for x. I'm going to take my second one because I like the negative being with the y. 5x minus 2y equals 1. Okay, 5x minus 2 times 6 is 12. Add 12 to both sides. 5x equals 13. x equals 13 over 5. So my ordered pair is 13 over 5 and 6. And then, of course, I can put both of those numbers back into my equations, both equations, and they should both come out equal, correct, whatever. Okay. Then, now look what happens when you get down to number 1. You're like, oh no, wait a minute. There's not an x or y that looks like they're the opposite. So this is where we're going to change our first equation, because I'm looking at this minus 2y plus 4y, and I'm thinking, hey, I can multiply my top equation times 2. 2 times 2y is going to give me 4y, and then I'll be able to use both equations. So I'm multiplying times 2 everything. So I'm doing 2 times 3x is 6x, minus 2y times 2 is 4y, equals 19 times 2 is 38. Then I have 5x plus 4y equals 17. My y's cancel out. I have 11x equals 48.55. Divide by 11, x equals 5. Now I can go back to either equation I want to, the original ones, and put that 5 in and solve for y. So I'll take the top one, 3x minus 2y equals 19. So I'll put in 3 times 5. So I have 15 minus 2y equals 19. Take 15 away from both sides. So I have negative 2y equals 4. Divide by negative 2. Y equals negative 2. So my ordered pair is 5 and negative 2. And just in my head, I'm going to take those two numbers and I'm going to plug them in my equation. So I'm looking at 3x plus minus 2y equals 19, this one. And I'm going to say 3 times x is 3 times 5 is 15, minus 2 times negative 2, which is 4. So I end up with 15 plus 4 equals 19, and that's correct. Now I'm going to go back to the second one. 5 times 5 is 25. So I have 25 minus 8 equals 17, and that also checks out. So I know my ordered pair is correct because I substituted it back into both equations just to check kind of in my head and make sure that they made sense. Okay, let's try the second one. This one, I can absolutely change either equation because either one, I'm either going to have to multiply the bottom one by negative 2 or the top one by negative 2. So let's just multiply the top one times negative 2 because I like that 4 right there. So I'm going to have negative 4x minus 2y equals negative 8. So now I have these two equations. My y's are going to cancel out. So I'm going to have x minus 4x is negative 3x equals 14 minus 8 is 6. Divide by negative 3. X equals negative 2. I'm going to go back to either one. X plus 2y equals 14. Negative 2 plus 2y equals 14. 2y equals 16. Y equals 8. So my solution is negative 2, 8. And I'm going to go back and look at I'll look at this one first. So I have negative 2 plus 2 times 8, which is 16. So negative 2 plus 16 is 14. Go back to the first equation. 2 times negative 2 is negative 4. Negative 4 plus 8 is 4. So it checks out for both of my equations. Okay, number 3. I'm going to run out of room. I'm going to multiply my second equation times negative 3. So my y's will cancel out. So I'm going to have negative 12x minus 3y equals negative 9. I'm going to go ahead and write my first equation again. 7x plus 3y equals negative 1. I end up with negative 12 plus 7 That's 5, negative 5x equals minus 9 minus 1 is negative 10. Divide by 5, negative 5, x equals 2. I'm going to take that 2 all the way over here, and I'm going to substitute it back in either one, it doesn't matter. 7x plus 3y equals negative 1. So 7 times 2 is 14, plus 3y equals negative 1. Subtract 14. 3y equals negative 15. Divide by 3. Y equals negative 5. So my ordered pair for number 3 is 2, negative 5. I make a big old mess. And if I put in 7 times 2 is 14, and 3 times negative 5 is 15, so I have 14 minus 15 is negative 1. 4 times 2 is 8 minus 5, so 8 minus 5 is 3. It checks out, so it's correct. One more. Okay. 2 more. Okay. Then you get to the ones where you're going to have to multiply both equations to make one of your variables have opposite coefficients. So I'm looking at my y's. I'm going to multiply this one times 2, and I'm going to multiply the bottom one times negative 3. So my first equation becomes 8x minus 6y equals 24. I'm just distributing. Negative 3 times 3x is going to be minus 9x plus 6y equals negative 12. Add those together. 8 minus 9x is minus 1x. My y's are gone. 24 minus 12 is 12. So x equals negative 12. I think I will go to my second equation. 3x minus 2y equals 4. So I have 3 times negative 12. 3 times negative 12 is negative 36. I add 36 to both sides. Negative 2y equals 40. Y equals negative 20. So my ordered pair is negative 12, negative 20. Okay, so that makes my 4 times x would be negative 48, and my 4 times 20 would be plus 60. So I have 60 minus 48, that's 12, and 3 times negative 12 is negative 36, and 2 times 20 is 40, positive. So I have negative 36 plus 40 equals 4. So it checks out, and it's correct. So this is about the point where you go, wow, sometimes this elimination is really easy, and sometimes this elimination is really hard. And that's when we're going to start talking about tomorrow. Is it easier well, we're going to look at graphs, but I want you to be thinking about, is it easier to substitute or eliminate or make a graph? Because there's times when each one makes it easier, and you're always going to want to be thinking smarter and doing the easy one instead of doing a whole lot of work for one that could have been done a different way. Okay, so I guess I'll look at my x's, because my y's I would have to multiply times each other. I have a common multiple of 12, so I'm going to multiply the first one times 3 and the second one times negative 2. 4 times 3 is 12x plus 21y equals 18. And the second one, 6 times negative 2 is negative 12x minus 10y equals negative 40. My x's cancel out. I have 21y minus 10, which makes 11y. And I have 18 minus 40, so I'm going to have a negative 40, 30, 22. Divide by 11. Y equals negative 2. I think I will use my first equation because it doesn't matter. So I have 4x minus 7 times negative 2 is 14. Add 14 to both sides. 4x equals 20. Divide by 4, divide by 4, x equals 5. So my ordered pair is 5, negative 2. And 4 times 5 is 20. Minus 7 times 2 is 14. So 20 minus 14 is 6. And the second equation, 6 times 5 is 30 minus 10. So 30 minus 10 is 20. So it checks out. All right, same thing when we get down to number 6. We just have to write the formulas now. Okay, so we have dollars and packages. Okay. We have the cost of the hot dog buns and the hamburger buns. And we know how many packages he's bringing. So let's let B equals burger buns. D equals hot dog buns. Okay, so I have B plus D equals 12 because he brought 12 packages. And I have $2 for hamburger buns plus 150 times hot dog buns, that's a D, equals $20. So it looks to me like I want to multiply this first one times negative 2. So my buns, my hot dog burger buns, cancel out. So I'm going to change this equation. I'm going to rewrite it as minus 2b minus 2d equals negative 24. My burger buns cancel out. So I have 150 minus 2, so that's going to be negative 50. Negative 0.5, negative 1/2 d equals negative 4. And if I divide by negative 0.5, it's like dividing by half, which is like multiplying times 2. Then I end up with D, which is hot dog buns, equals 8 packages. I'm going to take my D back into my burgers plus dogs equals 12. Burgers plus 8 equals 12. Hamburger buns equals 4. So I have 4 burger buns, 4 packages of burger buns, 8 packages of hot dog buns. That equals 12. And if I do 2 times 4 burger buns are $2 each, that's $8. 8 times $1.50, that's $12. So $8 plus $12 is $20. So it checks out. All right, number 7. Last one. Okay, we have movie tickets. We have adult cost, and we have children cost. So the Lee spent $31, so that's going to be 2 times the adult cost plus 3 times the children's cost equals 31. And the Macias have 3 adult tickets plus 5 children's tickets equals 49. I'm going to end up having to multiply both of them. So I'm going to multiply, I'm looking at my A's. I'm going to multiply the first one times negative 3 and the second one times 2. Distribute all the way through, and I have negative 6a minus 9c equals negative 93. And the second one's going to be 6a plus 10c equals 49, and 49 is 80, 98. My adults cancel out. I have minus 9 plus 10 is 1c, and 98 minus 93 is 5. So children's tickets cost $5. All right, let's go back to, I guess, the first one. 2a plus 3c equals 31. 2a plus 15, 3 times 5 equals 31. Take 15 away. 2a equals 31 minus 15 is 16 because 15 and 16 is 30, so 15 is 16, so it's going to be 16. So I divide by 2. So the adult tickets cost $8. So the adult tickets are $8, children's tickets are $5. So if I buy 2 adult tickets for $16 plus 3 children's tickets, that's $15. So 16 and 15 is 31. And for the Macias, 3 adult tickets is 24 and 5 children's tickets is 25. So 25 plus 24 is 49. So it checks out. Okay, it's just kind of a harder process. Sometimes it's easier, like at the very beginning, you were probably like, oh, this is so easy. Now it's getting a little bit harder because we're doing multiple changes to make the equations eliminate. And like I said before, in the next couple days, you're going to start thinking about when is it easier to substitute, when is it easier to eliminate, and when is it easier to use the calculator, because of course, there's times you can use your calculator. So I will see ya.